Okay, so what we're going to try to do here is replicate this table right here, this graph. This is a reflection density curve, and we want to replicate that. Now, we know some basic facts about logs. We know that when we have a log of 0, it's 100%. And when we have a log of 1, it's 10%. And when we have a log of 2, it's 1%. And when we have a log of 3, it's 0.1%. But for reflective densitometry, we're going to be in the range of 2 or less. When we get into transmission densitometry for film, we would be 3, 4, or 5. Okay, so these are the basic facts of logs. Logs base 10. The other thing we know is if we think about photography and the Stouffer scale, either for cameras making line negatives or halftone negatives or color separations, or for transmission Stouffer scales for plate making and things like that, we know that every time we change the density by 0.30, it changes the exposure by 50%, half, or twice double the amount. So if we carry the scale out to 0.6 and 0.9 and 1.2 and 1.5 and 1.8 and 2.1, so these are increments of 0.3, 3, 6, 9, 12, 15, 18, 21. We know that it's always half. So half of 50 is 25, half of 25 is 12.5, half of that is 6.25, half of that is 3.125, half of that is 0.6, and half of that is 0.8. So these rules go together. Let's color code this for a second here. These rules go together. Okay, and then the other rule we know is, again, from the Stouffer scale, a single step is typically 0.15. So when you have a density change of 0.15, we know the exposure changes by the reciprocal of that would be 1.4127, right? So let's see, the reciprocal of that is 1.14, right? So we can add the 0.3 rule to the 0.15 rule, which is 0.45, and then 0.75, 1.05, 1.35, 1.65, 1.95. So half of 70.8 would be 35.4, and then half of 35.4, almost 36, would be 17. That gives you 34. 0.5 gives you 35. 5, 6, 7.7. That gives you that. Half of 17.7 is almost half of 18 is 9, so we'll call that 8.5. Let's call it 8.8. This half of that would be 4.4, and half of that would be 2.2, and half of that would be 1.1. So these go together. And then the third thing we could do, actually the fourth thing we can do here, paper is about 95% brightness range using 457 nanometers, TAPI, Technical Association for Pulp and Paper Industry. And that density is about 0.06. We also know in photography that we have the 18% photographer's gray card. And the 18% gray card is typically around 0.7447 density, somewhere around there. That's 18% gray card is Munsell N5. The Munsell value scale goes from 0 to 10. Halfway between 0 and 10 is 5, so that would be a middle gray in the Munsell system. Okay, and then what I want to do here is, once I realize I have a 1 is 10, I can subtract 0.3 from these. So let's do that. Let's repeat this. So we know that when we have a density of 1, we have a factor, a reflectance of 10%. So 1 plus 0.3 would be 1.3, and then 1.6, and then 1.9, and then 2.2, right? So that would be half 5, half of that is 2.5, half of that is 1.2, 0.25. Half of that is, let's call it 0.65, 625, and that's good enough. But that was adding from 1. Let's again subtract from 1 instead of adding. So 1 minus 0.3 would be 0.7, and 0.7 minus 3 would be 0.4, and 0.4 minus 0.3 would be 0.1. So now you have to double these, right? So 10 goes to 20, 20 goes to 40, and 40 goes to 80. So what we have here, let's give you another color code here. So let's look at what we just did here. The basic rules of logs, factors of 10. The 0.3 is half or double rule. The 0.15 Stouffer scale. And then once we know the 1 and the 0.3, we can use them to add and subtract. And the 18% grade card one. So now if we take all this data and we just sort it. So what we just did here is using the basic rules and facts of math logs, we reconstructed the reflection versus density curve. Note that it is not a straight line, therefore it's not linear, it's not arithmetic. It is logarithmic or exponential. So think about this. If you have 100% reflectance, you should have 0 density. Half of the reflectance will give you 0.3. Half of 50 is 25, which will give you 0.6. Half of 25 is 12 and a half, and that'll give you 0.9. So that's the log curve.